Hi guys, in this example we're going to take a look at how do we solve quadratic equation using quadratic formula in the case of an application problem. So imagine yourself throwing a ball up in the air and you watch it land. What happens is the ball travels like what we call a parabolic motion. Okay, and so this is the same kind of thing. So you have a firework, it's shot upwards from the ground so that it'll move like this. So it starts over here and moves like a parabola and then it lands right here. All right, so they tell you that the initial velocity is 139 feet per second, but you do not need it because that's already part of this equation. So they give you the equation that the height at time t is equal to negative 16t squared plus 139t. Okay, what you need to understand is that this height that they give you is asking you how many seconds will it take to reach a height of 278 feet. That's what you need. So you need to make this height that they gave you right here equal to this specific height, and then you need to solve this for t. So you're gonna get an equation that is similar to what we considered in the previous example because it's not going to be in standard form. The reason why I say it's not going to be in standard form is because on the right hand side you're supposed to get 0, but you don't have it. You have this 278. So you need to subtract 278 from both sides of this equation to make it into standard form. So I will get negative 16t squared plus 139t minus 278 equals 0. So that's a crucial step that you need to remember because this kind of question will be everywhere. It will be on tests, quizzes, and so on. So please remember how to do it. But because once you do it, all you have to do is just put it in Desmos and it'll automatically give you your answers. You might just have to round it to a certain number of decimal places, but other than that, that's basically it. So let me show you how easy it's gonna be. So if let me see if I can put this side by side. So I am gonna put my ABC. So A is negative 16, B is positive 139, and C is negative 278. So looking at the discriminant, it looks like it's positive. So I'm looking at two solutions here, and basically that's it. Like these are your two solutions. So 3.12 if you round it to two decimal places, and 5.57 if you round to two decimal places. So remember, the next number tells you whether to keep it as 2 or change it to 3. Same thing here. The next number after this one tells you whether to keep it at 6 or change it to 7. Now, if you're not sure you want Desmos to round, there is a function in Desmos called round, and you're just going to put round, and then you can copy this number and put a comma and let's say two decimal places, and it tells you that's 3.12. So if you want the other solution, also copy paste that to two decimal places. After a comma, put how many decimal places so you want. So it tells you that at 3.12 seconds and at 5.57 seconds, the rocket is going to reach this height. Now, why do I have two solutions? Why is it going to happen at two different times? So notice that if you were to draw this height 278, so this is like the 278 height from the ground, right? So this distance from here to here is 278. The rocket will reach this height at two different times, over here but also over here. So that makes sense that about 3 seconds and then another 2 seconds after, it'll reach the same height, and then it's gonna drop all the way to the ground.